So we are going to listen from Marvin Moon here, the kind of electric utility perspective, and see, from your perspective, what are the barriers and the ways to overcome these barriers to install more, maybe solar capacity. So I'm going to ask Omar, please come in. Omar, to introduce you before.
Okay, great. Our next speaker is Marvin Moon. Marvin Moon actually came to speak to us at one of our IGERT courses, and he basically charmed the room, and we were so impressed with Marvin's approach at LADWP to hear some of the great projects that he works on that we asked him to come back and be part with us today. Marvin Moon, thank you.
All right, well, thank you so much. It's really a privilege to be here and talk about things that we do and share with you, and because this is all up our alley. I think we found the presentation. Okay. My talk is, I'm going to be talking about the challenges of integration of renewable resources from, of course, the utility perspective, because that's where I come from. Basically, I'm going to touch on reliability. I'm going to talk about renewable portfolio standards, our future mix, where we are, where we're going, and particularly challenges and solutions. That's kind of the heart of it. I'm also going to talk about the role of smart grid and network integration. Okay, so basically, every utility is supposed to have a integrated resource plan. It's basically a roadmap on how you want to move forward strategically. And if you go to the department's website, ladwp.com, you can find our integrated resource plan, and it tells you step by step the programs we have in place to achieve a number of strategic initiatives. The 5 of them in particular are, of course, we want to ensure reliability. There's only a few things you can give your customers: reliability, customer service, and low cost. They're all very challenging because they're interconnected. Secondly, of course, we want to reduce our greenhouse gas emissions by 39% by 2020, below 1990 levels. That's part of AB 32 and some other things we got going. We want to, of course, increase the integration of renewable energy. Currently, in 2010, the utilities were supposed to be at 20% renewables. Water and Power met it. Some other folks didn't. And now there's a state law that says that we have to be at 33% by 2020. That's only 8 years away, so it's going to be a challenge as well. And of course, we want to increase smart grid investments. We want to promote customer efficiency and the environmental effects, and also electric vehicles as well. And of course, there's another law that came out of California, and EPA is a little related to it, and that's on ocean cooling. Because, we have 3 coastal plants, and they use ocean cooling to cool them down and doing it for decades. Well, now we can't do that anymore. So we're going to be phasing out the use of that plant by plant. In fact, over the next 15 years, we're going to have to redo about 70% of our generation mix. Now, Water and Power is a little unique from other utilities because back when they did the dereg, a lot of utilities sold off the generation or transmission and so on. We kept it vertically integrated. So we still have all the generation mix. We have power coming in from the Pacific Northwest, from Utah, from Arizona. We have in-basin generating plants. We own 25% of the transmission capacity in California. And, of course, we have our own distribution system as well. Okay, so where are we going? As far as our energy mix right now, a few years ago we were at 44% coal. There's a state law for that too. You can't renew your coal contracts. In other words, they put it doesn't say that. What it says is that the CO2 levels on your contracts has to be below a certain level, and magically that break point is about coal. So we have 2 big coal plants. We did have 3. We got out of one of them. We still have the Navajo plant and another one in Utah. And so we went from 44% coal, now we're down to 39%. In 2020, we'll be down to 20, let's see, I can't even read my writing. 27%. And then our last contract expires in 2027, then we'll be out of coal completely. So as we move forward, we're going to be having our coal mix is going to go right in 2020, we'll be at 27%. Our renewables will be at 34%. That's by state law. Our large hydro is at 8%. In fact, that's what we are now. And of course, we own part of a nuclear plant in Arizona. That's another 9%. And natural gas, of course. Now, you don't want any one of these boxes to be too big. Otherwise, you end up with something like the oil embargo in the 70s, and all the utilities were burning oil. They got caught, and they all had to do the generation mix. If you look over on the right side, it's a little hard to read, but it talks about we're going to have solar and wind and biogas, And there's a geothermal component to it as well. Okay, so obviously, it goes without saying, renewables have their challenges. And of course, one of them is intermittency. The wind doesn't always blow, the sun doesn't always shine, the weather changes, it's very independent. Sometimes it goes, sometimes it doesn't. Often, like on our wind farms, most of the power comes at night when you don't need it. So there's a lot of variability, little control. There's very few resources you can actually control. What are some of the renewables you can control? Geothermal. Yeah, it's 24-hour source. That's like the holy grail because it's flat loaded. In fact, if we had only 500 megawatts of geothermal, we could have done our 20% renewables just with that, but we don't. But we own a bunch of stuff in the Imperial Valley. We're going to be building some in the next few years. Geothermal's one. What's another one? Biogas, exactly. We get biogas from landfills, and we get some digester gas from like the Hyperion sewer plant. We burn it. It's counted as renewable. And the other thing, too, about biogas is, of course, they can clean it up. They put it in gas lines. We can burn it in our plants without having to build a whole lot of new generation. Okay. The other thing is geographical challenges. Of course, you got to go where the wind blows. You got to have land for solar plants. You have to, you got to go where the hot water is for the geothermal. There's some limitations there. Also, there's a huge synergy between water and power. If you go with solar thermal, you need water for that. There's also those pump storage stuff. You need water for that, of course. There's a lot of geographical challenges. But the good thing is, here in California, we're within 100 miles of LA. We have good geothermal resources in the Imperial Valley and in the Owens Valley. We've got wind resources in the Hatch Peas and Palm Springs area. We got land in the Mojave Desert for solar and locally. It's a lot of good resources within an arm's length of LA. Okay. Also, existing infrastructure capacity limitations. You were talking about the storage over here with transmission limitations. I'll give you an example. If you have a wind farm and your load is going up and down and up and down, and you got to get it over, you got to get it to LA, you can't hog up your transmission line with all that variability. So you have to firm and shape your power. So like in the Pacific Northwest, we have 3 wind farms along the Columbia River Gorge. We have to pay BPA to take that power and use their hydro to even it out and schedule it so it'll fit on the transmission line coming down to LA. And of course, that costs money. It probably jacks up your cost about 20% to do that. So that's one of the challenges as well, is just getting the capacity. Also, try to build a transmission line. It's really challenging. We tried to build one there a few years ago called Green Path out to the Imperial Valley. You never heard so many people get upset, because it went through the pristine desert and everything. But all that to say, it's tough. Okay. Existing infrastructure, higher cost of maintenance. These things take a lot of maintenance. I'm going to be real truthful with you. We built a wind farm up in the Tehachapi's. It's called Pine Tree. It's 135 megawatts, the largest municipally owned wind farm. It's like the Golden Gate Bridge. We have crews that are dedicated. Their whole job is to tighten bolts. So when they go through all the 100 wind turbines, then they go back around and do it again. It's nonstop. Also, maintenance. You crack a blade, you do anything, everything's 200 feet up in the air. There's only a few cranes in the United States that can actually get up that high. So maintenance is quite a challenge for a lot of these things. And of course, when you have a maintenance, you need people to take care of this stuff that have the expertise. And so we're actually developing a new workforce. We have a new classification as we're hiring high school students to teach them work ethics. It's called the Utility Pre-Craft Training Program. It's to get them into the workforce. We have them working on solar jobs, weatherization, and home upgrades, efficiency projects, and so on, and then get them into the workforce. So it's not a flash-in-the-pan job. This is something they can make a career out of at the department. So you need a capable workforce. Also, your assets. Everyone says, well, let's put storage units in every neighborhood. Do you know how much effort it would be to maintain all that? Ideally, you put the stuff close together so you can have that workforce work on this stuff, and they're not spending half their time in travel time. So that's another aspect as well. Also, co-location. You want to have things that are synergistic. For example, one of the solar farms we're building in Adelanto is also a huge switching station where we have all these transmission lines coming in from out of state. So we have a workforce there anyway. We just had a lot of extra land. Same, we're doing another one in Pine Tree. We already have a staff there taking care of all the windmills, so we can take care of the solar as well. So you want to get that co-location thing going. You also want to put it right next to your existing transmission lines. I think I already mentioned that. Okay, regulatory. What's in and what's out? The definition is always up for grabs. There's always someone trying to tweak the definition. For example, methane. Is that renewable or not? Depends where it came from. If it comes from a landfill or a sewer plant, it's renewable. If it comes out of the ground, it's not. Hoover Dam, is that renewable? No, it's not. Not according to the state of California. That's large hydro. Doesn't count on your goals. It's still no emission, and we've used it for years, but it's just all what's in the definition. And you want regulatory certainty. We did a repowering at one of our generating plants. Repowering means rebuilding. And it turns out that the work we did didn't quite qualify for all the new rules, and so we're going to have to redo it again. So you want that certainty. Conflicting mandates. There's credits for solar. There's credits for charging electric vehicles. They're different. They're not interchangeable. I think there's a lot of opportunity there, and of course permitting as well. Okay, so solutions. Backup generation is one solution. Some people are building wind farms with a gas unit associated with it. Firming and shaping, I talked about that. Energy storage, we talked a lot about that. There's a picture there of one energy storage unit we built. It's 1,200 megawatts, one of the biggest in California. I think there's only a few. I think it's number 2. They actually built that back in the 70s because they thought they were going to build a nuclear plant in LA, and this would even out the load. It turns out they never built the nuclear plant, but this thing has saved our bacon, and it's perfect for renewables because you can store, it's a 1,200 megawatt plant. Also, look at that graph in the lower left. Energy storage. You talk about electric vehicles. The bottom graph is a typical electric vehicle charging graph where the peak is at night. Our wind farms peak at night. So in a way, it's like customer paid storage, and we didn't have to pay a dime for it. Okay, so anyway, there's also new methods of storage. But I got to tell you, it's expensive. We looked at putting a lithium-ion battery at one of our wind farms. It turns out the battery system would have cost more than it was to make the power. So all I have to say is it's going to come a long way. It's going to get cheaper, and particularly with secondary use for batteries on EVs. And of course, I mentioned co-locating. Modernizing plants. We're redoing a plant in Long Beach. Doing some of these. It was an old boiler plant. Boil the steam, do a turbine. It took a day and a half to pump that thing up. We're replacing it with 6 quick turbines. They're like big jet engines. So in 10 minutes, we can get up to 600 megawatts. That's one of the ways you can integrate renewables as well. And it's also more efficient. It doesn't use ocean cooling and so on. Okay, so a couple more key things. I mentioned geographic diversity. Don't put all your stuff in one basket. You want to put them in different places, so if something happens, you're not affected. Also, get your energy mix to be not just one type of technology. You want to use existing transmission land and right-of-ways because it's hard to put new ones in. Maintain operating flexibility. And then there's a clustering effect that happens. Over where we built our switching station for our wind farm, there's a whole bunch of other developers that are doing wind farms and solar farms. We're going to be upgrading 2 transmission lines down to LA to support all those future projects. And of course, we want an ownership position, so we're in it for the long haul. And energy efficiency is also important. We want to reach our goals with that. And smart grid, of course. With all these technologies, people using solar on their houses, using EVs, the power just doesn't go downhill anymore from generating down to the customer. It's going everywhere. It's coming out of the customer's house, it's going onto the grid, back into the other people's houses. And so as far as electrically, the system protection aspect, the voltage stability, all those things have to be taken into account, voltage imbalances, and in consideration of putting these things online. And it's just an example of how the true integration involves buildings, intermittency, base loading, fast startups, intermittent loads, base loads, and storage as well. It's all a big piece of the puzzle to put together. So I'll quit with that. It's not that I just like cars. This is the fastest electric vehicle made. It's a Shelby Arrow. But anyway, I don't know if you want to do questions now or later. All right. Well, thank you, folks.
Thank you.